Good morning, everybody. Thank you so much for joining us today. We really appreciate you taking the time out of your work week, especially given that we are in the midst of summer. It is maybe a little harder to stay in front of our screens, but here we are, and we're going to learn a lot of information today. Mainspring Energy has a wealth of knowledge, and not only that, their revolutionary technology is second to none. I'm really excited to bring this information to the forefront. Before we kick things off, I just wanted to kind of tell you a little bit more about Centurion Technologies, because I do know that we have some guests today that may not be familiar. We are a supplier of everything alternative energy and technology. It's obviously becoming so important and ingrained in our everyday life. From battery storage to EV charger, solar panels, fuel cells, and this crazy awesome technology from Mainspring Energy that kind of takes fuel and revolutionizes the way we get to use it. So my name's Ashley. I'm with Centurion Technologies Marketing. And then I wanted to introduce you to Craig Kuchbal, but unfortunately, he had a commitment that he could not be pulled away from. So he brought in his right-hand guy, Scott Amaduri, and Scott's with Enerlogics, and he's a key partner of Centurion Technologies. So hello, Scott. Thanks for being here.
Thanks, Ashley. I'm excited to learn more about Mainspring's technology.
Right along with you. And I feel like we have to give Craig a little bit of grief since he's not here and he's on the golf course instead.
Of course.
Feel like he deserves that. So Scott and I are your hosts today. Please use the chat feature. Submit any questions that you have ongoing. We will save those to the end, and every question submitted will be answered. If we can answer them, we will go ahead and intercept those for our host today. But please submit questions through the chat. I did want to remind you that this is being recorded and is shared on our social platforms. So just keep that in mind as you are sharing your own video image. Maybe you'd like to disconnect that at this time. Please be sure you're on mute. And then I'm going to let our amazing host go ahead and introduce himself. I know we did put his bio out there, but Shalaw, how about you go ahead and say hello to everybody?
Thank you. Thank you very much, Ashley. Much appreciated. Hello, everyone. Very happy to be here today. Thank you, Ashley and Centurion, for providing the platform for us to talk about Mainspring and also the linear generator as a product. My name is Shalaw Mohammed. For those that do not know me, I go by Shaw. I've been with Mainspring for about 9 months now. Prior to that, I was in Cummins. In Mainspring, I am within the sales engineering team. And our focus within that team is to provide solutioning, scope, and estimation for our EPC project, and along to support our sales team and also our resellers and partners with technical questions and questions about installing our project. Prior to that, in Cummins, I was in Cummins for about 10 years, and half of my career was focused on selling and installing lean bare natural gas gensets. So anything natural gas related is close to my heart, and very happy to be here. And prior to that, I was in University of St. Thomas, getting a bachelor's degree in electrical engineering. I'm an advocate for clean energy and very happy to be here to be talking about a great one as well. So with that being said, I'll go ahead and get started with the presentation. All right. Ashley, we're good? Perfect.
Looks great. Thank you.
Okay, definitely. All right. So just for everybody on the call, the way that I'm going to be presenting, I'm going to take up the entire 45 minutes most likely. We have, as Ashley pointed out, we have Q&A toward the very end, which I'll be more than happy to take any questions at that point, but I'll just kind of power through the presentation at this point. The presentation is going to be composed of 2 parts. First part is going to be an overview of the company and high-level features of our product. And then the second part of the presentation is going to be a technical quote unquote deep dive into our product and how are we able to achieve certain features that are state of the art in a sense. So with that being said, we'll dive right into what Mainspring is. So Mainspring was founded by 3 Stanford engineers in 2010. And they kind of set out with an approach to generate clean, reliable, and affordable electricity. Obviously, the research led to the innovation of what we know today as a linear generator. And fast forward to now, we have a product that is commercially available and viable and installed across multiple Fortune 500 customer sites and leading utilities. Our first product went into the field in 2020, so we've had 4 years of reliable, commercially available product. The Mainspring team obviously is a very diverse and talented group of people. The mission that we all carry is from our founders, which is providing affordable, reliable, and clean energy for all. We also have investors that share the same vision because they have been the entirety of their investment period. They've been investing in technology, green energy technologies, and technologies that are just affordable and clean and reliable. In terms of what we provide as Mainspring, we obviously provide two things. First is the product itself, and then the second are a set of services that we provide along with the product. So in terms of the product, I'm going to mention a few features of the product. And one thing to note on this slide is I will try to take, on the technical slides, I'll try to take a deep dive into certain aspects and certain features and show you how we're able to achieve these. But first foremost, our product is 250 kW linear generator that is contained inside a standard ISO container. And this is a 20 by 8.5 standard ISO container, fits into a parking space and is scalable. So you can add as many units in parallel as required for your site, and they'll be able to operate together with no issues. The product is fuel flexible, which means that it can run on any gaseous fuel as long as in a gaseous state. So it could be natural gas, biogas, hydrogen, ammonia, and so forth. And it would not really have any performance derate. Again, I'll talk in the technical slides, I'll talk about how we're able to achieve that. Another important thing is that we can run in any ratings or operation mode. So we can run either in prime power, we can run in backup, we can run as solar firming, whatever the required site is, because of our capability to load track, because of our capability to be dispatched, because of our capability to run on multiple fuels, we can really change the operation mode, and we're very flexible to that. And last but not least is resiliency. Resiliency is very important. Customers would like to have an asset that is both prime and can run in backup, and we can exactly do that. Again, we'll talk about it in more details in the technical slides. And because the way we handle the reaction inside our reaction zone, or in other words, our engine, we do it in a low temperature reaction, which we don't really foster an environment for NOx production, which means that we have near zero emissions, one of the lowest emissions profile in the industry and in the technologies altogether. Because it's a ISO box, and it has ratings such as UL and IEEE, is relatively easy to install and relatively easy to interconnect. And in terms of the services, what do we provide? We provide O&M service with every single package, and these O&M services are done entirely by Mainspring at this point. We monitor our product closely. The product has a lot of sensors and power electronics, so we are able to pinpoint if something goes wrong. We'll be able to monitor that. And also, if it needs to dispatch somebody to the site, we're able to do so. We also offer financing. So if there's a certain hurdle rate that our financiers are looking for, our partner is Nextera. They would be able to come into the mix, and if the IRR makes sense, they will be able to finance the project and charge you on an ASA rate. That'll be zero money down on your end. And we also offer, as I stated, an EPC package. So once a customer comes to us with a certain set of issues, we'll be able to define what the problem are. We'll be able to define the solution, scope it, estimate it for them. And then when the contract is won over, we will be able to install the entire turnkey solution to them. So it's kind of like, this is the problem, we'll turn the keys over to them. So that means that we install the product, we interconnected both electrically and gas, and be able to turn the package over to them toward the very end of the project when it's all finally interconnected. Last but not least, the fuel supply will be able to support with procurement of those, help you set up with our partners that have a fuel supply. This is usually in the alternative fuels or the new fuel category. If it's a simply natural gas, you're just adding another meter, so that's not really that difficult. All right, so this is just a map of our ever-growing footprint nationwide. As I mentioned, our first unit went into the field 2020, and we've been very busy installing more units since then. We have a long backlog of projects coming down the pipeline. We've made steady progress, and as you can see, we've been able to penetrate into different markets such as CNI and mobility market. Some of our customer logos on here, so I'm not going to take a deep dive. In total, we have 50 plus years because of our O&M contract. So we're able to beat that NERC availability rate to date. So this slide just talks about the use cases that we typically see ourselves in. This is not necessarily the only use cases that we see it. This is just 4 of them that we normally come across. So the first problem that a customer tried to solve for, obviously with the aging electricity infrastructure, the rates of electricity is going up. The electric utilities are raising that on regular basis. So a lot of customers are hit with these expensive rates, hit with these big utility bills. So they approach us, and we can install one of our units, run in prime power on site with a minimum import from the utility. So we sync with the utility. Utility is there still to back the system up in a sense, but we're just offsetting the cost of the utility. And the next one is emission. Because of our low profile emission profile, we're able to help customers achieve their sustainability goal much faster than they had originally planned for. Because of the available technologies out there right now, it's either the clean technology is either not dispatchable or it is not able to run in backup. We're able to be dispatched, run in backup, and run for as long as the gas is available. So it is kind of all-inclusive package. We're able to help customers reach their 2030 goals, 2050 goals much faster than they had originally planned for. Resiliency, as I stated earlier, customers would like to have an asset that can run in prime, that is permittable, which is clean, run in prime, at the same time be able to run in backup in case of utility outages. We've seen it all with the climate change and the hurricanes and storms passing by. I personally see outages almost every month in the local utility that I live in. And this is just if I were a customer, I would like to have some sort of a backup to be able to ride through those outages. And last but not least is speed to power. Certain customers require power now, especially with the EV and mobility market. They require a recharging station, but unfortunately, most of the time, the utility cannot provide that capacity right away. They usually give them a timeline of 3 or 4 years, but that's when we come into the picture. We can install these units relatively quick, less than a year, be able to interconnect it and start operating and operate in island mode. And when the utility rolls around, we'll be able to change our operating mode into something that fits into the mix with the utility. So I'll expand on this a little bit more in the next slide. And this is what I mean by changing and operating flexibility. So in the first picture here, this is where the customer wanted to have capacity immediately, but was not able. So they would approach us. We would install our units, depends on the size of the site. And because of our load tracking capability, we're able to serve the customer with the required power needs. And when the utility comes to site at certain points, you don't have a stranded asset because we can then change our operating modes. We can probably peak shave if the rates is structured in a way where it makes sense for us to peak shave, or we could play the backup where we only come into the picture when there's an outage with the utility, or we can do an offset of the utility cost. Still let the utility be there. We sync into the voltage or frequency there, and we just run and provide the KW for the site, which means that we're taking the risk of the energy cost and also the risk of the utility away from them and providing the site power needs. So just a quick comparison between us and other technologies out there. One thing that I struggled with when I first came here, obviously, so linear generators is a new category of power generation. I don't think there's really any technology out there that can be compared to us from an apple-to-apple point of view. I don't say this just because I work here, but I really think it is the greatest thing when it comes to generation technologies. But still, we need to compare ourselves with what's available. Customers are faced with these options all the time in the market. This is the alternative market solutions. You're coming across recip engines, you're coming across fuel cells, you're coming across turbines. But we do really believe we're best traded for power generation across those different technologies. And this comes in, especially when you're looking at comparing yourself from a CapEx point of view, OpEx point of view, efficiency point of view. We're really all together, we have the lowest cost of ownership, the lowest cost of lifetime cost of the equipment, because we have low maintenance costs, we have high efficiency, and we have relatively lower OpEx compared to some quote unquote very green technologies out there. So altogether, that makes us preferable. And also we have low emissions profile. A lot of customers are looking for this. Makes us permittable, makes us a non-stranded asset down the road, especially with the ever-changing landscape of policies when it comes to emissions. We're dispatchable. We're not only dispatchable in the sense where you give the signal, but we're also long duration. If you look at certain assets, you dispatch it, but it likes to run in base load. It does not really like to load track, ramp up, ramp down its output. It just likes to run in a certain base load and never changes output. That's not necessarily us. We can run, we're clean energy. We can run, we dispatch whenever you want it, start really quick within a short period of time and be able to load track. Last but not least, fuel flexibility. Again, it goes back to the point, you don't have a stranded asset. Things happen, certain fuel may be cheap and available today, it may not be tomorrow. And certain policy may drive you to use certain fuel in the future. It is important to account for those unknowns in a sense and have an asset that can take in all of these different fuels. So how do we sell our project? I touched base on this a couple times on the slide. We obviously, one of the most common way we sell these projects is a turnkey solution. So the customer approach us and say, I have this problem, and we turn around, we go visit the site, we do modeling for them to understand their ROI, the financial returns and so forth, and build a financial case for them. And once they agree to that, we will do site visit, try to solution, scope it, and estimate what the entirety of the project cost from an equipment point of view and from an installation and interconnection point of view. We submit that to the customer, and the customer could make a decision as a whole for the whole project, not only for the equipment. And we will then go ahead and install this project for them and only get them engaged again in a sense when the project is ready to be dispatched and operational. We interact with the utilities, both gas and electric, and be able to get this going. As I mentioned earlier, the gas supplier would be a customer's responsibility in this scenario. This is usually when, if it's natural gas, just another meter, not really that difficult in a sense. And if it's renewable gas, we will be able to help you partner with other people to get you the right fuel on site. Now, a financier can come into the picture and change this slightly. Instead of a cash purchase, it could be an ESA, an energy service agreement, which is pretty much just a KWH you buy from a financier. So you put zero money down and they're able to charge you a certain amount. And last but not least, you could just buy the equipment and do the EPC yourself. We're still going to be involved in a certain fashion to make sure that things are installed correctly and according to our guidelines. But in the end, you'll be able to purchase this equipment. But that's, so far, that has been kind of the least common one versus the full turnkey solution. All right, so again, I've touched based on this. With every equipment going out there, there's an O&M contract. And on top of the O&M contract, we do have a group of analytic teams switching in the US and also overseas that are constantly monitoring these packages. We have a lot of sensors, we have a lot of power electronics on board that we know exactly what's going on with these packages. So we're able to pinpoint issues relatively quick. As a matter of fact, the most recent statistic that was given to me was about 90% of the issues that arise can be remotely troubleshooted. So we don't even need to step on site, because we are constantly monitoring this, so we know exactly when this unit would be down, we'd be able to troubleshoot it and get it back online. And this feeds directly into our ability to beat the NERC availability rate to date. Since the start of our company, we've gotten numerous recognition. One thing that I personally hold dear to my heart is the most recent recognition for the IEEE. So IEEE Emerging Technology Award recognizes exceptional achievements and outstanding contribution that made a lasting impact on technology, society, and engineering profession. This kind of included the invention of radio, for example, the invention of circuit boards, the invention of machine learning devices. And as a matter of fact, one of the most recent one in 2022, NASA won this award for their Mars drone helicopter. So we're very happy, very humble, very proud to be recognized by IEEE for our technology. It just again recertified the fact that our technology is really an innovation and a state of art when it comes to power generation. So that concludes the slides about overview of the company. What I'm going to do in the next set of slides is take a deeper dive into the technical aspect of our technology. So for the engineers on board, hopefully you'll be able to get more out of this few slides. So first and foremost, before I joined Mainspring, I just looked at linear generators, looked at the attributes of it, obviously the features. I was really impressed. And the first question in my head, like, what is the science behind it? Why is it so amazing in a sense? And I really expected some level of rocket science-y and nuclear level technology, but it was really not that. It comes down to simple and basic concepts, proven concepts that have been around for centuries. And basically, we have a concept that says every time you have a fuel mixture compressed inside in a confined space, there will be a point where this mixture will react or combust. Right? In case of engine, it will combust. In our case, it will react. When that reaction happens, which is at point B, the pressure and temperature inside that chamber it shoots or exponentially increases to the point where it will be a reverse effect on whatever the mechanism was pushing in the first place. So if it's piston pushing in a cylinder, it will have a net force out on that piston, or an oscillator in our case, it would have a net force out on the oscillator. And at point B, it's pushing back and you have that energy available. You can do whatever you want with it until it gets to point D. When it gets to point D, your exhaust ports, your valves are getting exposed at that point, and your reactant or your combustion mixture leaves the chamber altogether. And this is exactly the concept that we follow. So to relate that to how we do it, our machine is super simple. We have only two moving parts, which are the oscillators that you see moving back and forth. The middle section is the reaction zone. That's the zone where that concept takes place that I just talked about. Then you have, next to that, you have linear electromagnetic machines, which are called LEM. These are the quote unquote alternator of our system. And then on the far ends, you have air springs, which are simply springs that are that use compressed air to use the bounce back energy. So as these oscillators are moving back and forth, they actually move on a cushion of air. Those air bearings are just simply like air hockeys wrapped around the oscillator. So we don't have any moving parts, which increases the reliability of the system. With only these two moving parts, obviously, it makes a really simple, highly reliable, and highly efficient system, because you're taking that fuel energy, converted directly into linear motion, and then you're converting that linear motion directly into electricity. So you don't have any rotational, linear to rotational, rotational to electricity. This is actually directly linear, and it's a very simple system. So how does the reaction take place? When you're looking at a screen on the right side of that animation, you'll see slots. Those are just simply openings. They're not valves. So we don't have any moving parts in a sense when it comes to that. Through those valves, we have the air and fuel that is pre-mixed in a chamber, will feed into this reaction zone. And these oscillators are pushing against each other to compress that fuel and air mixture. And remember what I told you in the concept, when you're compressing that, the pressure and temperature of that mixture goes up, which means that these molecules are moving around, hitting each other really fast. It gets to the point what a reaction occurs. And the reaction is simply breaking down of those molecules and restructuring the molecules in a new form. And when that new form molecule happen, they restructure at a lower state of energy. So we have excess energy in a sense available, which pushes back on the oscillator. When that pushing back happens, then we're taking, the oscillators are moving, we're taking energy out in the LEM machine, in the electrical part of our equipment. And we're storing the rest in the air spring, and the air spring provides that bounce back energy to start the next cycle. So as simple as that. We repeat that cycle over and over again to get the required output. So again, old concept. The only difference is we've been able to marry this old proven concept with modern technology, power electronics, and softwares and sensors, and be able to come up with something really simple, really reliable, low maintenance, high efficiency, and simply put, amazing. So we're able to monitor and control the compression ratio of those oscillators, and that makes us fuel agnostic, which I have a whole slide on that. So the next concept is the electrical part. This LEM machine, by the way, is designed by Mainspring altogether. So in electricity, we have, for those that are not electrical engineer, we have a concept that's called the Faraday law. The Faraday law says every time you have a moving magnet inside a coil of wires, you actually induce electricity. And as I stated, we have magnets on the oscillators, okay? And then that moves inside, underneath coils of wires inside the LEM machine. So this is half of the core that you see here. The previous slide, the animation was a single core. Single core has 2 oscillators. This is, we're just showing half a core to get the point across. So the reaction is on the right side, the air springs on the left side. So we're just showing one LEM at this point. So as this LEM, the oscillator is moving, you'll be able to see the current induced on the lower left portion. So we have the magnets moving back and forth. And for those that are electrical engineer, the first thing that you should notice is that that waveform does not look like anything we can use, because it has an envelope shape and it looks like it's a, in a sense, weird cycle. Well, you've got that right. I mean, we technically, as the LEM is moving back and forth, it happens at 12 cycles per second. And the waveform that's produced, the AC waveform that's produced from there, is not really that usable, because that's, you know, we're just trying to take the energy out and most efficiently turn that into electricity. So at this time, because of the envelope shape of the waveform, and sorry, I forgot to mention this, it has an envelope shape. That's because as the magnet is moving back and forth, they're at a 0 velocity when the reaction happens. Then they speed up, they're at maximum speed in the middle of the LEM, and they slow down toward the air spring. So you have this envelope shape, and you pretty much repeat that over and over again. So what you see here on right after the graph, right after the animation, that is the real waveform that comes out of the machines. So what we need to do is convert that to something useful. And the way that we best do it in electrical engineering is we convert AC to DC, DC back to AC to get whatever the waveform or the voltage, amplitude, and the frequency that we want. So at this point, we convert it to through LEM inverters, which are simply rectifiers. We convert that to a DC bus. Well, the DC bus still is not clean. So we have to smooth it out. And in order to smooth it out, we just use capacitors, smoothing capacitors. Excuse me. And we also, to uphold the DC bus, we use internal, not too big, relatively small batteries to uphold the DC bus for our linear generators. And then we take that DC bus, convert it to AC, which we simply use off-the-shelf grid tie inverter. In our case, it's Dyna Power inverters, 125 kW per each core, so 250 for the entire package. So what the end result is, we get 480 volt, 60 hertz electricity. And this slide just summarizes what I just talked about. So you take this waveform that's not necessarily usable, you convert that to DC, DC back to AC, and you're getting your required waveform. So as you can see, our specs are 480 volt AC, 60 hertz, 3-phase 3 power, and 250 kW unit. We do have certifications that are required by the utility, which are the UL 1741 SB. We also have IEEE 1547. And we also have the UL 2200 for the package. So altogether, this is, we've been able to come up with a package that is take an old concept, proven concept in a sense, that has been around for centuries, marry that with modern technology and power electronics and software controls, and be able to come up with something that is extraordinary. So I touched base a couple of times on our fuel flexibility, capability, and how we can change fuel on the fly. I wanted to spend a little bit of time here and explain how we're able to do this, because this is actually a huge, it's an amazing feature. I'm personally very impressed by it. Before I get into how we do it, I wanted to talk about that every fuel has a different reaction point. So when you're compressing a fuel, then that fuel only reacts at a certain point, at a certain temperature and pressure. So give you the example, if I have two oscillators, for hydrogen, they probably react right here. For natural gas, they probably react right here. And for ammonia, they probably react right here. So you have to really compress. Now, if you look at a traditional engine, where you have a crankshaft, the connecting rods and the pistons moving inside a cylinder, they've built that particular engine for a particular fuel. So let's say if it's natural gas, you need to compress it all the way up to here, and then that's what the reaction happens. Well, now what happens if I put hydrogen? Well, if I put hydrogen, the reaction happens here, but I'm compressing it still because mechanically I'm tied to a crankshaft that it's telling me I need to combust in a sense for natural gas. Well, the moment if hydrogen reacts here or combusts here in a sense, then the rest of the work that I'm doing, I'm working against the energy that was given to me. So I'm derating my equipment quite a bit, which is in retrospect, that's why most of the current engines, you can't just really change the fuel on the fly. Well, that's not necessarily the case with us, because we can control and monitor the reaction inside the chamber. We can control, and we can do that through the position of our oscillators. The oscillators have position monitoring sensors on them, so we know exactly where that oscillator is, and we can actually control it within the width of a paper. So we know exactly when that reaction happens. And the way we have inherently designed the oscillators, they're hollow cylinder equipment. The only weight on them is really this magnet. So it's relatively easy to move them around. So when a reaction happens, they propel back, and we know that we've changed the fuel. So we can immediately adapt this new compression. You put in hydrogen, it realizes that it's compressing right at this point, something happened, a reaction happened, versus what it was in the previous cycle. Let's say if it was ammonia, it was reaction would happen here, but now it's pushing back at this point, so it adapts to that. And the sensors and the electronics will be able to pick that up within a cycle or two, be able to manage and adapt to the new compression. So we have a varying compression capability, which makes us fuel agnostic. So you can change the fuel on the fly without even noticing it. It just could be just a matter of switching, mechanical switch, to take fuel A to fuel B, so natural gas to hydrogen, hydrogen to ammonia. It could change it, or it can even do a blend of those at any point. The blend has to obviously happen outside. But the important thing to note is that we can control that compression, and we can change the fuel on the fly without any prior notification to the equipment, or without any change of performance and output. All right, so now we have the package, and I want to keep time in mind, we have 10 minutes left here. We have the package, as I said multiple times, is easy to install, and it is easy to install because we only have 3 connection points. We have an electrical connection point, which is 480, three-phase 3-wire system. This is typically 2 sets of 250 kcmol coming into our equipment. The gas connection is 1-inch threaded pipe. We consume about 2.2 MMBTU at max rate. Roughly, we're just looking for 2 MMBTU from a consumption of 1.9-ish from a consumption point of view. Flow could be a little bit higher than that. And we're looking for somewhere 8 to 25 PSI, so 15 PSI not nominal. From a foundation and clearances point of view, the package is a standard ISO container. So we're looking at a 20 feet by 8.5 feet with 9.5 feet height. We require 6 feet permanent clearances around the LGen, and those need to be marked off with bollards. But the bollards need to be removable. And the 6 feet is simply just to make sure we have enough clearance for the door. We do, however, require 30 feet scheduled clearance on the exhaust end and 10 feet scheduled clearance on the intake end. And the 30 feet scheduled clearance is for us sometimes on major rare events, on major maintenance, we may pull the core out. As you can see in the lower right picture, pulling that core out requires some space. So you can definitely use the space for your day-to-day business. But when we pull that core out for any, let's say, major events or rare events, then we would require that space. So again, it is scheduled clearance, not necessarily required clearance. However, the space around the LGen needs to be compacted to 95%. It could be soil, it could be concrete, it could be asphalt, whatever is preferred, as long as it's not necessarily too, as long as it's not necessarily soft ground. And this slide is just to kind of show you how we are doing multiple configurations. So we said it's scalable. You can put as many units as you want to get to your required kW value. The spacing between them is shared, which means that in the 6 feet clearance can be shared between 2 units, as you can see here. The 30 feet can be shared, the 10 feet can be shared. So you actually have a relatively smaller footprint when you're looking at multiple megawatts. All right, so modes of operation, we do have 2 modes of operation. We can run in grid parallel mode, which means that we are syncing into utility, frequency and voltage, and we're just offsetting utility kW. And typically this is done by us installing a meter at the incoming utility and be able to monitor what the incoming kW is and try to drive that to the difference. This is quite a difference between us and certain other technologies. Certain other technologies cannot take the meter directly. You have to install a third-party controller, transducer, whatever that ends up being. But we can just take the meter data right into our controller. Our controller, you can set a minimum kW, or you just ask it to drive it to 0, whatever is your required preference. Then the machine will calculate and figure out what's the minimum import, and it will drive itself to that because we can load track. Now, in case of a utility outage, we can also run it back in island mode. So with adding a couple other equipment on site, we'll be able to determine an outage automatically, open the main breaker, and be able to change the mode of operation within the LGen and start establishing voltage and frequency for the site. And because of our load tracking capability, ramping up and ramping down, we're able to meet the required load on site without any issues or third-party support. This is just to kind of further explain our island mode capability. This is a huge differentiator between us and certain other technologies that are clean, right to our level, but they can't really load track. They like to run in base. We can load track, basically go up to whatever the maximum amount of our output is. And whenever the load drops below our nameplate value, then we can just ramp down our output and be able to match the required load on site. All right, so from an emissions point of view, because we are doing we're doing a reaction, we don't do combustion, because the reaction inside the reaction zone is a low temperature reaction. We actually don't foster an environment for NOx production. So if you think of a recep engine, what happens is that they're pushing the piston against a cylinder, confined in space. And at a certain point, if it's a diesel engine, because of that compression and ignition happens, or if it's spark igniters, you're introducing the ignition, the spark ignition yourself. But then that ignition is is actually it's an explosion. That explosion happens at a certain point and it expands out. Well, that certain point creates a hot pocket or a hot spot, and that creates a lot of NOx. What do we do? Because ours is low temperature reaction and it's uniformly reacts everywhere. Because we're compressing that gas, it uniformly reacts everywhere. We don't have any hot pockets. So we have near zero NOx when it comes to the NOx profile and other emissions as well. As you can see, when we're comparing ourselves to engine and other technologies, relatively low. And when it comes to hydrogen, we're obviously, again, very close to zero. Sound profile, we're 70 dBA at 6 feet. I'm probably talking to a 55 dBA right now, so you can easily hold a conversation next to this unit. I used to be in the engine world, so I'm used to seeing, usually in the engine world is on a 21 feet, that's how it's measured. not 6 feet. So I just did an online calculator. Don't quote me on this. I took that 70 dBA at 6 feet and converted it to what is it at 21 feet. It turned out to be 61 dBA. So you can easily hold a conversation, and this actually matches well with my experience being next to an engine versus being next to these ones. This is relatively quiet. You can hold this conversation without really any issues, without me even raising my voice. You can have a normal conversation next to it and have no issues. So I'm going to end the slides here. This is the final slides with the case study. This just recently got a lot of media coverage. One of our projects. This is actually the biggest EV charging station in the US, microgrid wise. The project is a leading leader in logistics for real estate, and they wanted to have a charging station in one of their shipping ports. And they approached the utility asking for 10 megawatts of power. The utility could not provide that capacity of power, so they gave them a timeline of 3 years for the power to be there. Well, they had an immediate need for that charging power to charge the trucks. So what they ended up doing, they approached us to provide 3 megawatt of power so that we can charge their batteries on site. They first had some level of batteries on site to meet the required need. So what we actually do in this project, we run Prime continuously to charge the batteries when the EV charging stations are not in use. And then when they're used, we're supporting the EV charging stations, and the battery obviously is supporting during those peak times. Now, when the utility gets to site, let's say in 2 years or 3 years down the road, we can, as I stated earlier, we can change our operations from Prime. We can be peak shape, depending on what the rate structure is. We can still offset utility costs, so run still Prime, charge batteries, support it, or we can run simply in backup when the utility is not available. So the impact that we had on this particular project, we're able to reduce their power need from waiting for 36 months or 3 years down to only 12 months, and be able to give them the power that they require. And this has most recently received a lot of media coverage, so that's why I wanted to cover this case study. We have other case studies that are purely just LGENs or LGENs solar farming, as in case of one of our customer Lineage. It's just units are firming the solar when the solar is available, or feeding the site when the solar is not available. So that brings me toward the end of the presentation. I really wanted to thank you so much for your time that you've given us today. I want also to thank Centurion and Ashley specifically for the opportunity. And I'll be more than happy to take any questions. I think my colleague has been answering some of the questions online, but I'll be more than happy to take some of that questions on here.
I can go ahead and read some of these. And I'm going to start with the last and work backwards. And as you said, some of them were answered in the chat. Scott asks, what kind of ramp rate for load following can the Mainspring generator achieve?
I just realized I was on mute. Yeah, I didn't freeze. But yeah, we can do about 10 kW per second when we're grid following. But in grid forming mode, we can actually be instantaneous with no issues. And the way we could do that is because we have, as I mentioned, we have a DC bus, and that DC bus is supported with batteries. Now, I don't want to take the battery conversation as a standalone conversation, because really intrinsic to our equipment is nothing you can tap into. We have certain customers that are thinking kind of outside the box and say, oh yeah, we can use the batteries for other things. That really is battery just to firm that DC bus. But because of that battery, we're able to take in 100% step load in island mode. But in grid following mode, we can do 10 kW per second.
Okay. Michael asked, how often should your genset be overhauled or maintained?
So the lifetime of the LGen itself is 20 years. We don't really have any major overhauls in a sense. We do have consumable, even though we don't have any oil in the system. It's a frictionless system. The only thing we have are seals in the on the ends of that oscillator. So as that oscillator moving back and forth, we obviously need to seal that environment so pressure can increase and we can foster an environment for the reaction to happen. Those seals do wear. They're graphite. Obviously, graphite is susceptible to pressure and temperature. They do wear. And the wearing time for those seals are dependent on the duty cycle and the runtime of the linear machines, which we'll be more than happy to, if you have a certain case scenario, we'll be more than happy to take that into consideration, talk to you about what the potential scheduled maintenance for those would be. But in terms of major overhauls, we don't really have a major overhaul.
There was a question regarding competitors. I know it was actually around the time you had the slide up. This is a revolutionary technology. In my knowledge is it's one of the first of its kind. So I don't know, what kind of competitors would you speak to?
Yeah, so we do see fuel cells as competitors in some of the projects that we're bidding. We see microturbines as competitors that we bid in. If you were to ask me from a technology point of view and the field that we're playing in, I would consider lean bare natural gas genset as competitor. But we do really, I mean, what we solve for, we could do so much better in a sense. If you look at a lean bare natural gas genset, from just purely from an emissions point of view, you would require to have after treatment solutions on there, which requires consumption such as urea. It has consumable item, urea. Is a third-party equipment that goes on top of your enclosure. I used to sell and install lean bare natural gas gensets, so I know a lot about it. It goes on top of your enclosure, so aesthetically it does not look that great. It is a third-party equipment, so it's a point of failure. It has consumable, it has maintenance that goes along with it, and maybe it could even fail during testing periods, which could cause downtime for your equipment. So when you look at it from a continuous run, being able to ramp up, ramp down, being able to be discharged for a long period of time, being able to run on natural gas, even though it's not the same technology, you cannot really compare apple to apple in a sense, but I would consider them as a competitor of ours.
We'll give just one more hot second if there are any other questions. We do have Shaw on the line, literally. So if you'd like to ask a quick question, please go ahead and do so. I will let you know too that I'd like to send this presentation out to everybody who attended today and gave their time. I'll also send the chat too, just because those were great questions and some were answered in the chat. This video will be on our YouTube page as well as the news section of CenturionTechnologies.com. I'd also really like to thank my co-host, Scott and Maduri. Thanks for being here and helping me put this on behalf of Enerlogics and Centurion Technologies.
Thanks, everybody.
If that is all of our questions today, I do believe we are at the end of our presentation. Thank you so much, Shaw, and the Mainspring Energy whole team who came together to put this on. Love the partnership. This technology is changing the game, and it's kind of fast forwarding some of our efforts. So thank you all for your time.
Thank you.
Great. Thank you very much.
Great job. Great job, Shah. Thank you, everyone.
Appreciate it. Bye.
Thank you.